Misalignment is the deviation of relative shaft position from the collinear axis of rotation when equipment is running at normal operating conditions. Even flexible couplings can only function with small amounts of misalignment. A misaligned machine can cause serious issues such as seal failure, bearing failures, energy loss, increased vibration, and excessive heat. So, it is important to detect the signs early on to prevent catastrophic failure. Some common signs that might indicate misalignment are: 1. The wear or failure of machine components. This includes coupling, bearings, belts, seals, or other parts. The wearing down of grooves, discoloration, or disfiguring. 2. Shifting or strain of attached piping or base plates. This creates abnormal stress on pump bearings, seals, couplings, and can possibly change the displacement of a pump. 3. Loose shim packs. This may be a sign of soft foot. For a number of reasons, your machine might not be sitting flush on the machine foundation. 4. Increased power consumption. Variables such as motor efficiency and load can greatly affect how much power is needed to run a machine and the associated costs. 5. Increased noise and vibration. If a machine is loud and vibrating excessively, it could be a sign of a number of things, including misalignment. Misalignment is a serious issue if unaddressed, but if you know how to look for these signs, you can successfully avoid damage to your machines and ensure optimal functioning.
Bonus. Good shaft alignment allows machines to run more efficiently, reducing power consumption while increasing output. Let's look at how it's done. Very common rotating machines in industry are pump and motor sets. When a motor runs, the shaft rotates and transmits power through the coupling to the pump. Forget for a second that we are aligning two machine shafts. Instead, imagine two simple lines that represent the shafts. The goal of an alignment technician is to adjust these two lines to be collinear. Collinear means that two lines are positioned as if they were one single line. In the real world, we aim to align the machines as collinear as possible, within tolerance, at the coupling or point of power transmission. Typically, the machines will be misaligned in two ways and in two dimensions. Let's visualize this. Vertical and horizontal. Both vertical and horizontal directions each have a combination of offset and angular misalignment. To measure, we rotate the shafts to find the relative positions between the two center lines of rotation. Once we know the